The question above says how many grams of methylacetylene, that is propyne, with the given structure will completely discharge the color of 8 grams of bromine. The question above says how many grams of methylacetylene, that is propyne, will completely discharge the color of 8 grams of bromine. Solution. Before we proceed, if you are yet to subscribe, kindly do that, and as well click on the notification bell so as to be notified as soon as new videos have been released. There is also a link to our Telegram channel in the description box. You can join our Telegram channel via the link for better communication. Let's continue. The question above has to do with decolorization, that is changing the color of bromine, and this is the properties of alkenes and alkynes. Here we have the alkyne compound here to be propyne. So if propyne is to completely decolorize the color of bromine, that means propyne is going to become more saturated, and when it is completely saturated, we now have it to be an alkane compound. So the next thing we'll be doing is to write out the chemical equation showing the reaction between propyne and bromine to become an alkane compound. So here I have the formula for propyne to be C3H4 reacting with bromine. You have that to be Br2. So when propyne is completely saturated with bromine, we'll be having it to be C3H4Br4. That is, it is now moving from alkyne to alkane compounds. It is completely saturated. Now coming back to the chemical structure given here, the structural formula given here, we have this to be, we have 3 lines, 1, 2, 3, which indicates that it is not completely saturated here, and also indicating that it is an alkyne compound. So with this here now, propyne is now completely saturated with bromine, that is, the color of bromine is completely discharged, or we can say bromine is completely decolorized. Now looking at the chemical equation above, we'll discover it isn't balanced. So the next thing to do now is to balance the chemical equation. Here we have 3 atoms of carbon, 3 in the product side as well. We have 4 atoms of hydrogen in the reactant side, and in the product side we have 4 as well. For bromine we have 2 present, and in the product side we have 4. So to balance bromine, we'll be adding 2 as a whole number here. So we have 2 times 2, which gives us 4. So that means bromine is balanced, 4 in the reactant side and 4 in the product side. Now having written a balanced chemical equation, the next thing to do is to proceed in calculating the mass of propyne, which is also known as methylacetylene, the mass of methylacetylene, which is also known as propyne, in the equation or in the chemical reaction. Now from the question above, we are given the mass of bromine to be 8 grams, but we do not know the mass of propyne, which serves as which is the unknown. So to make this easier, given the atomic masses of each of the elements present, and we can determine the number of moles based on the chemical equation written above, we can proceed to calculate the reacting mass of each of them. So after calculating the reacting mass of each of the compound, then we can determine the mass that will react, the mass of the unknown that will react in the reaction. Let's start with propyne now. We'll be calculating the molar mass of propyne now. So molar mass of propyne, which is C3H4, is given to be the sum of the atomic mass of the elements present in the compound. So carbon, the atomic mass of carbon is 12, and we have 3 atoms present. That will be 3 times 12 plus atomic mass of hydrogen is 1, and we have 4 atoms present, so we have 4 times 1. This gives 36 plus 4, which is equivalent to 40, the unit grams per mole. So to calculate the reacting mass now, we'll be applying the formula in calculating mass, which is number of moles times molar mass. So the reacting mass of propyne now, the number of moles based on the equation, we have 1 as a coefficient. So I'll just say 1 mole multiplied by 40 grams per mole, which gives 40 grams. So the reacting mass of propyne is 40 grams based on the equation above. For a complete reaction, we must have 40 grams of propyne. Now for bromine now, molar mass of bromine, formula Br subscript of 2. So the atomic mass of bromine is 80, so we have 2, and we have 2 atoms present. That will be 2 multiplied by 80, which is equivalent to 160 grams per mole. We're calculating the reacting mass just as the way we did for propyne. We'll say reacting mass of bromine equals the number of moles from the equation. We have that to be 2, so we'll say 2 per unit moles multiplied by 160 grams per mole. And this gives 320 grams. Now, according to the chemical equation above, 40 grams of propyne will require 320 grams of bromine for complete decolorization. In the question above, we are made to understand that 8 grams of bromine is present, and we have to calculate the mass of propyne that will be required. So to do that, we'll be using the relationship saying that if 40 grams of propyne requires 320 grams of bromine, then X grams of propyne will require 8 grams of bromine. So that from here we'll be cross multiplying indirectly to get our unknown, which is represented by X. So we say X equals 40 grams multiplied by 8 grams divided by 320 grams. Calculating this, we have 320 over 320 grams, which is equivalent to 1.0 grams. This implies that 1.0 grams of C3H4 methylacetylene will be required. And with this, we've come to the end of the solution to the question. From our calculation, we've gotten the mass of methylacetylene that will be required to be 1.0 grams. That will be all. Do not forget to subscribe to this channel and as well click on the notification bell so as to be notified as soon as new videos are being released. There's also a link to our Telegram channel in the description box. Kindly join our channel via the links for better communication. Thank you.